Good morning, students. How are you? So, I welcome you in this session of question discussion of fluid mechanics part 3. This could be our last session on fluid mechanics. Okay. So, firstly, make sure the screen is visible to you and audible to you. If is it so, please write this thing in the chat box. We will wait for 1 minute or 2 minutes more. Let the others to be joined. Meanwhile, you can ask any kind of doubt if you have from the previous class. And so you are Shiva, right? Good morning. How are you? Make sure the screen is visible to you and audible to you. Okay. Let me know in the chat box. I think there is an internet issue with your side, I guess. Okay. So I'm starting the lecture. So very first question that on your screen is this. So two narrow bores of diameter 5 mm and 8 mm are joined together to form a U-shaped tube open at both ends. So if the tube contains water, what is the difference in the height level of two limbs of the tube? Surface tension is given to you, angle of contact is given to you, gravitational value is given to you, and density of water, obviously, if it is not given, we know it. So try to solve this question. It's a very important question and has previously asked in GMAIN 2023. Try to solve this question. Giving you 1 minute to solve this. Okay. Am I audible enough? Okay. So there are two U-tubes which is given to you, two limbs which is connected to form a U-tube like this. Okay. So the radius of this limb, these are the diameters. So radius of this limb will be, let's say, this is the bigger limb, so it has a diameter of 8 mm. So radius will become here 4 mm. And this, let's say, R2 will become 2.5 mm. So these two initially will behave as a capillary, and we know that H is equals to 2s cos of theta divided by R rho G. So firstly we will see ki how much water will be arise in this limb, bigger limb. Let's say that is H1, and then we will see how much water will be arise in this. Let's say H2, and this is H1. Then we find out the difference between them, H2 minus H1, which is delta H, in which we are interested. So for H1, this will behave as a capillary. So we can apply this formula. 2 into, what is the value of S or T? Surface tension, either you can write it by S or by T. So T is given to you 7.3, 10 raised to the power minus 2, multiply by cos theta. Theta is the contact angle. Contact angle is 0. So cos 0 will become 1. Now divided by R rho G. R is 4 mm. So you can convert it into meter here. 4 into 10 raised to the power minus 3 meter. Rho is 1000 and G is 10. So this can be cancelled out from here. Now H1 you have as 2 into 7.3, 10 raised to the power minus 2 divided by 40. Similar manner में you can calculate H2. H2 will be 2s cos of theta because surface tension will not change and contact angle also will not change because the material of this U-shaped tube is same. So 2 into 7.3, 10 raised to the power minus 2 divided by, instead of 40, you will have here is 2.5 into 10. Okay, because all the data is same, only radius you have to change. So if you calculate this H1 minus H2, this value is bigger because this is lower here. So H2 minus H1 is equals to 2.2 into 7.3, 10 raised to the power minus 2 divided by 10. And you can take it out or you can multiply this 10 inside. This will become 1 upon 25 minus 1 upon 40. And when you calculate this, it will become 2.19 mm. So this much is the difference in height of this U-tube limbs. Got it? I hope you got this answer. Any kind of doubt you have, you can ask any point of time. Okay. Now we will move to the next question. This. The height of a liquid column raised in a capillary tube of certain radius when dipped in a liquid A vertically is 5 centimeter. Now, if the tube is dipped in a similar manner in another liquid B of surface tension and density double the value of liquid A, the height of the liquid column raised in liquid B, it would be. So let's say this is a pot of liquid A and this is the port of liquid B. Okay, so different liquid is filled in this. When you put the capillary here, you will have a height, let's say HA is 5 centimeter. So it is being asked that what is the height in this? If let's say the surface tension of this liquid is S, and what is given as density, and density of this liquid is, let's say, rho. So here surface tension is 2s and density is also 2. So we can say that HA is equals to 2s cos of theta divided by R rho G. Okay. Now we can say that H is directly proportional to S upon, if all the things are same, then we can say that H is directly proportional to S upon rho. Got it? Now, so we can say that HA is equals to SA K times SA over rho A, and HB also will become K times SB plus rho B. Okay, you are saying A. Okay, you got it correct. So from here you can say that HB is equals to K times, because we know SB is 2 times of SA. 2 times of SA, and density is also double. This will cancel out, so this will become same, 5 centimeter. But answer is given you in meter. So you have to convert it into meter. It will become 5 into 10 raised to the power minus 2, 0.05 centimeter. Very good. Keep it up. This is the correct answer. Now, try this question. Here, consider a cylindrical tank of radius 1 meter is filled with water. The top surface of water is at 15 meter from the bottom of the cylinder, which is given in the question figure also. Now, there is a hole on the wall of cylinder at a height of 5 meter from the bottom. From the bottom, here there is a hole. A force of 5 into 10 raised to the power 5 Newton is applied at the top surface of the water using a piston. Piston की मदद से we are pushing this water down with a force of this. Now the speed of efflux from the hole will be, all the thing is given to you. Now, what is the formula for speed of efflux? So velocity, yeah, speed of efflux. Speed of efflux is square root of 2 by rho of liquid P minus P naught plus 2GH. This is the formula we have derived. Okay. If the simple thing is has been asked to you, speed of efflux, and all the data is given to you, then you do not know, make it lengthy question by applying Bernoulli equation and all. Okay, we can do it by applying Bernoulli equation to this point and this point. But what is the need if we know the formula and the values is directly given to us? Let me save the time. So firstly, you have to understand what is the pressure this. Okay, so this is the pressure here, we will say, and this P naught is the pressure of Got it? So here if we will see, we have applied a force on them. Got it? And due to this piston, this water, you can say it is a sealed down water. Sealed, this is sealed. So pressure, we cannot say the pressure acting on it will be atmospheric. No, it is with that we have applied plus atmospheric pressure. Atmospheric pressure तो इसे प्रेस कर ही रहा, लेकिन in addition to that we have a force. So due to this force, what is the pressure? Pressure will become here. Hello student, how are you? So pressure will become here force upon area. Force we have as 5 into 10 raised to the power 5. Area, the radius is given to you. Area of this cross section will be the base area. So it will become pi r square. Now 5 into 10 raised to the power 5 divided by pi. Okay. So this is the pressure by this piston. Okay. Now this P naught is the pressure here, and this point is outside the liquid, so we can say that this is the value of atmospheric pressure. Okay, so now all the data you have, you are saying the option C. Let's see. So 2 by rho is given to you of liquid, which is water. 2 by 1000, this will become, this P will become finally P plus P atmospheric. Okay. And minus this P node is P atmospheric. So finally you will have 5 by pi 10 raised to the power 5 Newton per meter square, or you can say Pascal, plus 2 times into 10 plus this height from the top surface is given by this. So this is 10 meter. Now let's just calculate it. So it will 5 divided by pi multiply with 2 divided by 1000, then multiply with 10 raised to the power 5, plus this will become 10 into 10 is 100 into 2 200 plus 200, and if you take the square root of that, it is coming out as a second. Yeah, so this pressure is not only 5 by 5, 5 by pi, it will become, because this is the final value we are taking, so 5 by pi minus 1.01 to 10 raised to the power 5. Okay. Then if you calculate it, it will come out as 78.17.79, or you can approximate 17.8 meter per second. So very good, you are absolutely correct. Keep it up. So now this question. This question is from NEET. Okay. Look how simple question has been asked in NEET examination. The viscous drag acting on a metal sphere of diameter 1 mm falling through a fluid of viscosity 0.8 Pascal second with a velocity 2 meter per second is equals to. So I'm giving you 1 minute to solve this question. Try to solve this question, find out the answer. What is given in the question? Diameter of the sphere 1 mm. From that you can conclude the radius is 0.5 mm or zero point 0.5 into 10 raised to the power 3 meter. Now, coefficient of viscosity is given to you 0.8 Pascal second. Velocity is given to you 2 meter per second. Okay. So all the thing is given to you. You have to apply the Stokes theorem or Stokes law. So have you find it out? Do it. The formula that apply here is F is equals to minus 6 pi eta r v. Now why this minus? Because this viscous force act in the opposite direction to the motion. Minus 6, 3.14 you can take approximately. It is 0.8 multiply by the radius 0.5 10 raised to the power minus 3 multiply with velocity which is 2. So it has become finally, what is the value? 6 into 3.14 multiply by 0.8 multiply by 0.5 multiply with 0.2. So it will become 15.072. 15.072 10 raised to the power minus 3. Then you can approximate it to 15 into 10 raised to the power minus 3. What? Newton. Got it? Everyone? Any kind of doubt? You can ask. Option A is the correct one. Now, the velocity of a small ball of mass capital M and density D when dropped in a container filled with glycerin become constant after some time. If the density of glycerin is d by 2, then the viscous force acting on the ball will be. Again, try to solve it. Any kind of doubt in previous questions, you can ask here. Now try to solve this question. Okay. So here we are provided with a small ball of mass capital M and density D. So when it is dropped in a container which is filled with glycerin, so after some time it attains a constant speed. The velocity is constant after some time. Now, when the velocity become constant, let's say this is the ball, so we can say that mass of the ball will act in the downward direction. In upward direction, what kind of forces we have? The buoyancy force, force of buoyancy or buoyant force, and the viscous force. So at equilibrium, because constant velocity means there is no acceleration. I will write it here. Constant velocity equals to, which means no acceleration. And if there is no acceleration, No external force. I will say it, no net external force, which means sum of the all the forces will be zero. So you are saying option B. Let's see. So FV plus FB is equals to mg. Now FV may we are interested, mg minus FB. Now FB we know, buoyant force is given by density of the liquid, volume mass of the solid, multiply by G. Now we know that density of glycerin is d by 2, which is just half of the this solid. Now solid की density we will give by mass upon volume of solid. Okay, mass of solid divided by volume of solid. Now density of glycerin is d by 2, so we can say that it is mass of solid divided by 2 times of Vs. So we will replace this value at this point. This is the density of glycerin. So Fb will become m upon volume of solid, 2 times volume of solid into Vg. This will cancel out. So finally what do we have? Mg minus mg by 2. So viscous force that the ball will face is mg by 2. You are absolutely correct. So have you applied the same concept or you have tried the different way? Okay. Now, very good. Now move on to next question. Everybody try to solve this question. Okay, very good. Try to solve this question. Everybody. A capillary tube of radius r is immersed in water and water rises in it to height h. The mass of the water in the capillary is 5 gram. Mass is given this time. Another capillary tube of radius 2r is immersed in the water. Means liquid is same, but the radius is doubled now. The mass of the water that will rise in this tube is the mass you have to focus on. Try to solve this. This is water. Report. Initially we have this capillary and then we double the radius. Okay. So in this h height tak the liquid will rise. Okay. May we will assume that up to h dash height tak liquid will rise. Mass here is 5 gram. Okay. So we know that h is equals to 2s cos of theta divided by r rho g. Now s is same, cos theta is same, rho density of water is same, g is also same, only radius is changing. Okay. But we have to consider mass also. Okay. Now h is equals to 2s cos theta divided by r. We can write the density as mass upon volume. It is mass divided by volume. That volume will come multiply by g. Okay. So from here we can say that h is directly proportional to 1 upon rm. R is the radius, m is the mass. So if we take this as h1, 1 upon r1 m1 and divide by h2, which is also 1 upon r2 m2. Now this will come up, this will go down. So h1 by h2 will become r2 m2 divided by R1 M1. R2 is the radius of this capillary, which is 2R. Mass we don't know. Okay. And another thing that we would know. Okay. So mass 2 divided by, what is the value of R1 here? R1 is small r, and mass that we have is 5 gram, which is 5 into minus, or you can consider into gram also. So the resultant we have is gram. Got it? Now, okay. So this, just a second, this R and R you will cancel. So finally, what do you have? H upon H2 is equals to 2 times M divided by 5. Okay. Although we also know H is directly proportional to 1 by R. Got it? So if we apply this concept also, that H1 upon H2 is equals to what? 1 upon R. So it will become R2 by R1. Now H1 is H. H2 we want to know. R2 we don't know, is 2R, and R1 is R. From here you can say that H2 is equals to H by 2. Okay. So put the value here. So it will become 2H upon H is equals to 2 upon 5 into M. This will cancel out. So mass you will have here is 5 gram. The same mass will be there. And why? Because height is H by 2. Height is decreased by 2 times. Okay. So, and radius is doubled. Because of this doubling in radius, this height is decreased. Same amount of the water will rise. Okay. So 5 gram is the answer. Have you got the same? Anyone? If you have any kind of doubt, you can ask right now. Got it? No. This question. It's a very important question and a little tough question it is. A train with a cross-sectional area S1, ST is moving with speed Vt. Yeah, obviously. You have find it correct. Mass will be 5 gram. M2 is 10 G. So where do we have mistakes? Have you made any kind of mistake here? H is 2s cos of theta r rho g. Yeah, this is correct. We have considered this density of the water into mass upon volume of the water. Okay. So if we kept it fixed, then H will become directly proportional to 1 by R. So from that, we have calculated this H by 2. And H is also inversely proportional to mass. So H1 divided by H2 is equals to M2 by M1. M1 is 5. Okay, okay. Got it, got it, got it. This is here too, na? This M1 will multiply here. And this 2 is come because of this, right? We have to do it separately, not combinedly. This will not valid. We have to do it separately. So for that, this will become 2h upon h2 m upon 5. So this h2 is h. Now the mass will become 10 gram. Got it? Very good. And sorry for this misunderstanding. Correct option is B. Yeah, you find it well and very good. Now try to solve this question. And instead of that, you will try this question first. So very important, conceptual wise. So a vessel is filled with two different liquid of density rho and 2 rho. This is rho and this is 2 rho. The velocity of the flow of liquid through a hole at height h by 2 from the bottom is. This is h by 2. This is also h by 2. And this is h. Now find out the velocity of this liquid right here. Okay. Try to solve this question. You have 1 minute. Not 1 minute. You will take 2 minutes. Try to solve this. Each and everyone. Try to solve this question. I'm giving you a hint here. Hint is that apply Bernoulli theorem. Bernoulli theorem is applicable in this question. Try to find the solution. Okay. So to solve these types of problem, we would consider a points. First point you will always consider at the top of the liquid. This is, let's say, point 1. And second, you will consider where you want to know the data. So we want to know it here, the velocity. The second point we will consider here. This is point 2. Now, have you find it out? Now, apply Bernoulli theorem at point 1 and 2. Okay. So this one end is exposed to atmosphere. So we know that it is P1 plus 1 by 2 times rho V1 square plus rho GH, which is the potential head, equals to P2 plus rho GH2 plus 1 by 2 times rho V2 square. Now we know that this is a very narrow hole. So the velocity of this cross section, which is moving down, with the velocity v1. This v1 is very less than this v. Why? Because equation of continuity, if you apply here, so the mass that come out from this hole, the same mass will be decreased from this vessel. So you can say that A1 V1 equals to A2 V2. Okay. So V1 here is A2 by A1 into V2. Now A1 is very greater than A2. So we can just neglect it. So V1 we just make it 0. Okay. Now because A1 is very greater than A2. Got it? Now this term will become 0. Pressure 1 here. This is just at the surface. So at the surface, this vessel is open. So atmospheric pressure will acting on this. P atmospheric. So you can say here that it is P atmospheric plus. Now this is important. How you are choosing this potential energy? Because for this potential energy, you must flow through this 2 rho density liquid, then to this rho density liquid. So firstly, this 2 rho is filled up to a height h. So 2 rho g into h. To reach this point, firstly we have to cross this liquid. So there will be a potential energy possessed by this liquid also because density is different. So this is 2 rho up to height h it is filled. So 2 rho into gh plus. Now this point. This point is about 2h distance above and density of this liquid is rho. So this is rho g into 2h equals to P2, pressure at this point 2. So pressure at this point 2 will become P atmospheric plus pressure possessed by this surface, because for this surface if you will see at this section the pressure will be exerted by this liquid. And what is that pressure? If you consider a point here at the cross section, at the intersection, so you will have rho g into h. So it will be rho g h plus. Then you have to come out to a h by 2 depth in a 2 rho liquid. So it will become 2 rho g h by 2. Okay. This much depth you have covered. Got it? Now plus 1 by 2 times rho v2 square. Now this P atmospheric and P atmospheric will cancel. This will become rho g h. This is rho g h. So this 2 rho g h will cancel out this. So finally you have 2 rho and this thing. What liquid is coming out? Liquid of density 2 rho. So here you will have to take 2 into. So this will also cancel out. This will become 2 rho gh here. And this side it is rho v2 square. This will cancel out this. So finally v2 you have as square root of 2gh. This is the final velocity or the velocity of efflux you can say. Now any kind of doubt? Anyone? Any kind of doubt you have? Okay. No. Next question. This, based on the same concept, try to solve this. A light cylindrical vessel is kept on a horizontal surface. Area of base is A. A hole of cross-sectional area small a is made just at the bottom side. The minimum coefficient of friction necessary to prevent sliding the vessel due to the impact force of emerging liquid is. We have seen a question, we have seen this type of question in the previous class where we have calculated the impact force. Okay, so try to solve this, recall that concept, try to solve this question. No. In the previous class, we have seen the impact force because of this hole. The water will produce as rho area of hole, okay, multiply by velocity of the hole. Velocity, the water is coming out, v square. No. So this is the force applied by the water on this tank, and this tank is placed on a surface. So if this surface has a friction, so the water is coming out, so force will be exerted in this direction, this work. So this friction surface will oppose this motion and apply a force of friction in this direction. So we need to calculate the minimum coefficient of friction that is necessary to prevent the sliding. So for preventing the sliding, this frictional force should be greater than or equals to this impact force. Now, if weight of this liquid is m here, this is acting downward in downward direction, and this is the normal reaction acting upward. So we can say that F is the limiting value for it is mu m into g is greater than equals to rho small a v square. Now, base area of this is given to you, capital A. Mass of the liquid, you can say density is mass upon volume. Okay. Now, mass you can replace by rho into V. V is the volume here. Okay. And volume we can say the height is h and the base area is A. So we can say that rho capital A into small. Okay. Now, put this value here. Mu rho into capital A G greater than equals to rho A V square. Okay. Now, this row will cancel out this row. Okay. So this GH now, this volume flow rate, you can calculate it by equation of continuity. So it is A into V, the area and the velocity from which the liquid is coming out. We can apply it here. So it is area of this base, velocity of this base is equals to, say this is V1, and small area divided into V. So V1 here is small a by capital A into V. Got it? Instead of writing this, we will write here is this. Because mass is continuously decreasing here. So we cannot say this mass is fixed. So we have to consider the mass flow rate here. Got it? So this is m dash, and it will become density into, this is the volume flow rate. Got it? That will become small a by capital A into small b. Got it? This will go upside. Just a second. So this is rho into v. So you can replace this v also. Got it? By a by a into v. ठीक है ना? So from that you can say, just a second, this is mu mg is greater than equals to rho a v square. We know that from equation of continuity, area into velocity of this surface is equals to small a into capital V. This is the volume flow rate which is coming out from this liquid. Got it? Okay. So yeah, option C is the correct option. It is the correct option. But what is the time now? It's 10:53. So I'm really sorry for that, because this question takes some time, but we don't have time. So I would say that I will solve this question in the regular class, and I will also consider it. Okay. And meanwhile, if you have any kind of doubt in the previous questions, and you can take the screenshot of the remaining question. You can take the screenshot of this question. This is the homework. Take the screenshot of this question. Have you taken it? And screenshot of this question. Have you taken the screenshot? These are the questions you have to solve. Okay. So this is it from my side, guys. If you have any kind of doubt, you can ask. Otherwise, you can leave. We will solve that question in the regular class because of the time foundation. Okay. So I will solve it in the next class. If you have any kind of doubt in remaining questions, then the rest we have discussed. So you can ask. Otherwise, the lecture is being over. Thank you so much for being attentive and being responsive also.